Welcome to the Science 1 class. Today we are going to learn about density. Let's see what is density. Density, it is a measure of mass per unit of volume of a material or a substance. How to find the density? By using a formula. Density is equal to mass by volume. What is the formula for density? Density is equal to mass divided by volume. To understand clearly, let's do one activity. Density is the amount of mass in a unit volume of matter. Every substances have different density. To understand this idea of density, let's do this activity in your home. Okay. First step is pour 1/4 cup of honey in transparent glass. Second step, pour 1/4 cup of colored water on the top of the honey. Third step, pour 1/4 cup of coconut oil on top of the colored water. Now notice how the different liquid from different layer. Why is it so? Different substance have different density, which means for the same volume, different substance weigh differently as they weigh. Heavier substance tend to settle at the bottom like honey, and lighter material like oil tend to float on the top. So from this we will understood density is the amount of mass in unit of volume of matter. Every substance have different density. Next we'll move to relative density. Look at the word relative. What does it tell you? It tells us that we are looking at the density of something is relative to the density of something. We are comparing the density of one thing to the density of others. But the question is relative to what? It's most typically the density of water. We look at the density of an object relative to the density of water. How do we define the relative density of a substance? It equals the ratio of its density to that of water. Yes, density of the substance over density of water. Can you tell me the unit of relative density? As it is the ratio of similar quantities, relative density has no unit. Relative density is the ratio, the density of a substance and density of water. Relative density compare the density of two substances finding their masses, but generally density of substance compare with the density of water at 4 degrees Celsius, because the density of water at temperature is 1 gram per centimeter cube. To find the density any other substance with respect to density of water at 4 degrees Celsius is called relative density. Next we will see floating and sinking. Whether an object will sink or float in a liquid is determined by the density of the object compared to the density of liquid. Density of the substance less than the density of the liquid, it will float. For example, a balloon which is less denser than water will float on it. Some substance having more density than water. For example, stone, it will sink. Next, we move on to hydrometer. Dear students, now let us study about hydrometer. Hydrometer is an instrument used for the measurement of relative density of liquids. It is based on the Archimedes principle of flotation. The construction of a hydrometer. It consists of a hollow cylindrical glass tube G. Its one end carries small bulb B, while the other end carries a long, narrow glass stem to make the hydrometer float on the liquid. The small bulb B at the bottom is filled with lead shots or mercury. The upper stem S is graduated to read the relative density of the liquid. The hydrometer is placed in the liquid whose relative density is to be determined. As the denser liquid gives higher thrust, the hydrometer sinks less. Similarly, the less dense liquid gives low upthrust and the hydrometer sinks more. The lower density numbers are at the top. Hydrometers may be calibrated for different uses such as lactometer for measuring the density of milk, saccharometer for measuring the density of sugar in liquid, and alcohol meter for measuring higher levels of alcohol in spirits. Next, we will know about lactometer. What is lactometer? Lactometer is a little glass instrument that tests the purity of milk based on density or works on the principle of the specific gravity of milk. An instrument to find out the content of the water in the milk or to test the richness of the milk is thus termed as lactometer. The lactometer consists of a long graduated test tube with cylindrical bulb with the graduation ranging from 15 at the top to 45 at the bottom. The test tube is filled with air. This air chamber causes the instrument to float. The spherical bulb is filled with mercury to cause the lactometer to sink up to the proper level and to float in an upright position in the milk. How does lactometer works? Working lactometer, it is based on the Archimedes principle. When we put the lactometer the liquid, it experiences the Bion force, that is weight of displaced fluid. Hence, measure relative density is the given scale of liquid. Until lower the density of liquid, further the lactometer will sink the lactometer. It works on the principle of gravity and milk. The construction of this instrument is very unique as there is a long vessel test tube, a meter bulb attached to it, so that whenever the milk is poured into the vessel, the meter bulb starts floating on it. The purity of the milk gets tested without any dilution of water content in it. These lactometers are for precision design, accurate measurement, and reliability. These lactometers are based highly at milk processing units like dairies. The average reading of normal milk is 32. Next, we move on to buoyancy. What is Bion force? Let's understand the meaning of the term Bion force by doing simple experiment. Take a bucket full of water. Try to push an inverted glass bottle in the bucket. What do you experience? When we try to push an inverted glass bottle into the bucket full of water, we have to apply downward force. It means bottle experiencing upward force. The upward force is due to force exerted by water on the bottles containing the enclosed air opposing the downward motion of the bottle. To take an empty plastic bottle closed with an airtight stopper, put it in the bucket full of water. What happens? Then an empty plastic bottle closed with the airtight stopper is put it in a bucket full of water. It floats in water. Now trying to push the bottle into the water, is it possible to push it easily to the bottom of the bucket? Why? It is not easy to push the bottle to the bottom of the bucket. This is because the upward force exerted by the water on the bottle opposes the downward motion of the bottle. Now release the bottle. If the bottle is now released, it rises to the surface of the water and floats on it. In above examples, the upward force experienced by an object immersed in any liquid is called the upthrust or buoyant force. This force acts as opposite to force of gravity. When a body is partially or fully dipped into a liquid, the liquid exerts force on the body. The force exerted by this liquid is perpendicular to the surface of the body and is equal to the product of pressure and area. At that point, the resultant force of all is contact force is called buoyant force. Have you ever drawn water from a well? You must have noticed that the bucket of water appears lighter under water but heavier as it comes out of water. The submerged object appears to lose weight in liquid due to upthrust or buoyant force. The property of a liquid to exert an upward force an object immersed in is called buoyancy. The buoyant force acting on an object depends on the volume of an object. The buoyant force is greater if volume of an object submerged in a liquid is larger. Density of liquid, the buoyant force is greater if density of liquid is greater. Next, we will see Cartesian diver. Cartesian diver is an experiment that demonstrates the principle of buoyancy. It is a pen cap with clay. The Cartesian diver contains just enough liquid that it barely floats in a bath of the liquid. Its remaining volume is filled with air. When pressing the bath, the additional water enters the diver, thus increasing the average density of the diver, and thus it sinks. Next, we will see Archimedes' principle. You have a beaker filled with water and put your index finger inside it. You will observe that the water level rises slightly. You put in two fingers, the water level rises a bit more. And how, when you put in your hand up to the wrist level, you will see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub he got in. He realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes up and keep this. He would come back to its scene. We have seen that when an object is placed or on the fluid, The fluid exerts a buoyant force on it, which acts upwards. The Archimedes principle goes just one step further, in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kilogram solid object and suspend it by a spring balance. The balance will read 5 kgs. Let this to be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is, and we keep a small container under the opening. Now slowly lower the solid object into the water. Now you will see that the reading will be lower number as compared to the previous case. Why is it that? Because of the buoyant force acting on the object. You have also noticed that some water was displaced. Now, in this context, we can say that the weight of this displaced water is equal to the magnitude of buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, then upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel weight, everything above the keel will remain afloat. That's because the water to applies an upward buoyant force on the ship, which is same as the weight of the water displaced by it. There's just one last concept. Yes, that is law of flotation. What are the laws of flotation? The weight of a floating body in a fluid is equal to the weight of the fluid displaced by the body. That what we learnt in Archimedes principle. The center of gravity of the floating body and the center of buoyancy are in the same vertical line. So, what is center of buoyancy? The point through which the force of buoyancy is supposed to act is known as center of buoyancy. That is shown in the figure. Underwater buoyancy. That's all today's class. Thank you, students. Have a good day.